Hi everyone, I'm Sal. For my capstone project, I sort of wanted to do something, work on a project a little closer to UMass Dartmouth. Now, if you've been in a room for more than 5 minutes with me, you probably know I'm involved in an organization called, oh, is it clicking? Oh, it's not working. Okay, well, I'm involved in an organization called the UMass Dartmouth Big Data Club. and yeah, so the Big Data Club maintains something called a Discord server, which is like a messaging app that club members can use to talk about data science and other cool things on campus. And so the club wanted to really track which members are participating the most so they can maybe reward them at the end of the semester. And to do this, they wanted to build essentially a machine learning model to identify when users ask questions related to data science in their Discord server. Now, of course, some questions are not going to be relevant. I think the last question that was asked in there was like Ben asking someone for ice cream. So we won't want to focus only on the ones that are relevant to data science. And so I gathered data from this Discord server, 72 questions, and I labeled them as data science or other. And if you know anything about machine learning, you know that that is not enough data to really do anything, especially because text data is really complicated. If you look at these two example messages that I have on the slide, they're both talking about Python, but one of them is referring to the reptile and the other is referring to the programming language, and obviously only one is relevant to data science. So how can we sort of disentangle these complex relationships with just a small amount of data? Fortunately, there's a tool for that. Deep in suburban Iowa, there's this essentially a warehouse with a supercomputer with hundreds of thousands of CPU cores run by a company called OpenAI, and it runs a program called GPT-3. Now, GPT-3 is a machine learning model that essentially generates human-sounding text, and it's been in the news a lot lately for its ability to do things like writing realistic-sounding news articles. But its real strength is its generalizability. See, GPT-3 is something called a transfer learning model, which means that it was trained on essentially a very large data set for a very general task, and it can be essentially tuned using small data sets, specific problems, to apply them to different, more specific tasks. So doing things like detecting tweets that contain misinformation, summarizing legal documents, or even identifying questions that are related to data science. And this diagram shows essentially how it was developed. So researchers took a massive neural network of about 175 billion neurons, trained it on a huge data set that was scraped from the internet. It's called the Common Crawl. It contains things like all of Wikipedia, hundreds of books, etc. And they trained it to basically fill in the blank. So predict which word comes next in a sentence. And by developing a model that becomes really good at generating text, you can sort of use it for different things. So my problem is classification. I wanted to apply GPT-3 to the problem at the Big Data Club. And there's two ways to perform classification with GPT-3. So GPT-3 is actually offered as an API. So the company OpenAI allows you to use it with something called an endpoint. So you essentially like send the request to their server. And the first is called the completion endpoint. So what the completion endpoint does is you give it a string of text and it tries to continue the pattern. So if you give it something like question, topic, question, topic, question, the next thing we'll try to spit out is the topic. So that's how you perform classification. And this is really useful because you can just show it maybe 6 to 10 questions, and it will be able to, you can teach it to perform classification and classify whether topic is, or whether a question is related to data science. But the problem is you need some way to choose those examples because it's really sensitive to how good those examples represent the problem. Now, there's another solution called the classification endpoint, aptly named, that's specifically designed for classification. And basically, to summarize the way it works is it performs a semantic search. So you give it a massive list of, let's say, questions in this example, and it searches through the ones that are most relevant to the input to try to predict the class. But the problem with this is even though it needs less data, it still needs hundreds or thousands of examples to work well. So there's sort of this problem of how can we use it with fewer examples than are necessary. So that's what my research in my capstone focused on, figuring out how to augment the number of training examples for the classification endpoint, select examples for the completion endpoint, and compare them to see which is better and see if these can actually perform or classify the topics of questions. So for the classification endpoint, I use a solution of data augmentation, which is essentially increasing the number of samples in the training data. So I thought to myself, GPT-3 is really good at generating text, so why don't we just use it to generate more examples, like brainstorming? This diagram sort of shows how that works. Basically, give it a bunch of examples of, let's say, questions related to data science, and we'll spit out more questions that are related to data science that are similar but also different at the same time. And so by doing this, basically I tested this on the classification endpoint to see its performance. And you can see if you look at the 0 here, that's just using 26 questions that I selected from the original data set. The model doesn't do much better than random guessing. It only classifies about 50% of questions with the correct data science or other label. But as we start allowing GPT-3 to add its own examples that it's generated, it actually increases the accuracy up to about 75% accuracy after about 10 or 1,000 to 10,000 questions. These are two different sets of data. So validation set is a set that we're using to optimize the hyperparameters, and test set is unseen questions, so questions it's never seen before, and that's really the one you want to focus on. So we can use the classification endpoint to sort of solve this problem relatively well, but maybe we can use the completion endpoint to potentially solve it even better. However, it's a little bit more complicated because this is an optimization problem, so we need to employ an optimization algorithm to do this. And because we're using text data, we can't just use like gradient descent like we learned about in Alpha's numerical optimization class. So I chose to use something called a genetic algorithm. And it's quite complicated, but in layman's terms, what I'm doing here is basically generating a number of different sets of questions. So like eight questions to give to the completion endpoint. And then we have a bunch of different examples of sets of questions. We evaluate how well they allow the endpoint to perform. We keep the ones that are good and get rid of the ones that are bad in terms of accuracy. And then the ones with the high accuracy, we generate new examples, new candidates, and sort of like reproduce them, create offspring. So it's sort of like the computer science version of natural selection. And over time, if we keep doing this iteratively, we can get sets of questions that allow the completion endpoint to perform really well. So the second thing I did was program this up and test it out to see if it could get better performance. And here are the results. I ran 3 trials. So the individual trials are on the left and the averages are on the right. And you can see that the completion endpoint actually on the validation set is able to achieve 85% accuracy, which is better than 75% on the validation set. And that's after about 40 generations of continually trying new sets. However, there's a problem, which is that if we actually look at the test set, which represents questions that the model has never seen before, we see a massive degradation of performance for the completion endpoint. So yeah, the accuracy drops from about 85% to about 67%, which is really bad. We don't want that. In fact, we prefer the consistency of the classification endpoint, which achieves roughly the same accuracy on both the validation set and the test set. So we were able to solve the problem of trying to predict data science questions in the big data club. Like we could deploy this model to their server. But the real question is, why does this work? Why do researchers care about this? And the reason is because think about how humans solve problems. We don't just spit out the first example we think of. Well, some students might do that, but if you're trying to solve it well, you'll take out a piece of paper, write down ideas, and compare which ones are the best. And this is called the hypothesis of extended cognition. So philosophers argue that the reason humans are so intelligent is because they can use external tools to essentially improve their brain's performance, like a paper and a pencil to write down ideas. And what I'm doing in this project is essentially just giving AI, like GPT-3, the ability to do the same thing. So some future work directions. You might think that 75% accuracy is not very good, but in reality, language is very subjective. And I found that the questions that it commonly mispredicted, my GPT-3 model, were actually the ones that were the most subjective. So if you hear the examples, I put them on the slide. Now you can see like some of them, like, are you coming to Big Data Club tomorrow? Is that really relevant to data science? I said that it wasn't because it's just related to the club, but Big Data Club is a club about data science. So maybe some people would argue that it is. And so some potential improvements to the study could be sort of employing data quality control. So maybe when GPT-3 proposes its own examples, you could have it sort of ask real people, okay, well, is this related to data science or not? And kick out questions that are like debatable about whether or not they are or they aren't. Could also use other optimization algorithms like reinforcement learning, or even, since the classification endpoint was more consistent, try to employ optimization on that tool as well. So to conclude, I found that the classification endpoint using GPT-3 could identify data science questions for Big Data Club at a 75% accuracy. I found that in order to attain this, data augmentation is necessary, and it works very well, increasing accuracy by about 50%. And by using data augmentation, we can sort of allow AI to solve problems more like humans. So before I end, I'd like to acknowledge the UMass Dartmouth program in data science for funding it, because GPT-3 is kind of expensive, the Big Data Club for providing the questions that were used in this study, as well as Professor Jan for his valuable mentorship throughout the project in the Capstone. Thank you. Yes.
In relation to the thing about how you come into the there's somebody recommended online a book by a guy called Stephen Yablo. It's called About This. The question is, what is language about? And that's
Yes.
so I'll send you.
Awesome. Thank you. Yes.
Ever using GPT for some kind of the customer service, automatic customer service department, right?
Yeah.
So I mean, you can classify what kind of questions people ask, and somehow you can direct to certain people, or even can answer things by itself.
Yeah, exactly. I mean, this is not just like a silly little thing that I did for Big Data Club. There are a lot of applications of this, and that's one of them. When you have those chat bots on the website and you ask questions, and it never gives you the right answer. Like using something like this could actually direct you to the page automatically. Yes.
Do you have to do any data cleaning for this and like language processing, or do you just feed in the sentences that you have to?
So that's a good question. So I did do a little bit of data cleaning to sort of select the examples that I wanted to use, and you sort of have to organize it into a file because the model is like a JSON file. But other than so, I had to parse the text. But actually, in sort of terms of, I think an earlier talk talked about like tokenization and stuff like that. That is all automatically done by the GPT-3 model.
Other questions? Yeah, I guess I have a
All right.
question I
Yes.
asked it before, but I forgot the answer.
Oh.
How
Oh,
does the
yes, yeah.
algorithm work in this case, and specifically things like crossover?
Yeah.
They're
So.
supposed to be splicing things
Yeah,
together?
so I didn't go too much into crossover, but basically what you're doing is so let's say we have 2 sets of 8 questions, right? It would pick 4 of them from one candidate and 4 of them from the other to create a new set and just selected randomly. Well, it's not exactly randomly because there's like methods to ensure that there's not duplicates and stuff like that, but more or less randomly.
Drawing from groups.
Mhm.
Okay.
Yeah.
Okay, we have time for another question, also from the remote people. Any questions? All right, if not, let's thank Sal.